Anyways, all right, welcome everybody. Right, it's just about four, so we'll get started in a minute here. But today is the Valentine's Day workshop, the Valentine's Day special. What does that mean for us? It means we'll be covering we're gonna be covering how to make an augmented reality like Valentine's Day experience for your significant other perhaps or to I mean just for the sake of it, like it is augmented reality. So we're going to be using a platform called XR Plus, which is a really cool AR platform. Lets you produce AR experiences with very little effort. But before we get to that, just some updates about the club, right? So we've talked about these before a little bit, but I just want to talk about them again. Workshop suggestions was a channel that was recently created to replace Beginner Accelerator. Beginner Accelerator back in the day was an effort where people recommended things that they wanted to learn, and I did my best to cover them. But it was more top down in the sense that I provided ideas for what we could go over, and then people kind of like voted on them, and then we did like a lecture recording on them. Hey, Tony, welcome. So now workshop suggestions is more of an opportunity for you to influence what our future workshops are going to be. And our future workshops can be any number of subjects. So please use that channel. Additionally, just wanted to talk about the Say Hi channel a little bit. We removed the button that lets you react with like the spam of those different the stickers, the sticker spam. Yeah, because it's very important to like help people feel welcome. So like when new people join our server, it really is great if everyone in the server, like whoever's present, right, makes an effort to actually ask people how they're doing, ask them why they're here. It's really important to like retaining those new people that are here and they're curious and they want to see what's going on. Additionally, GDA will likely be incorporating as a nonprofit in due time. So that's some exciting news. That doesn't really mean much for our members, but it does mean that we can talk to high schools more easily to follow through with that vision of expanding to some Florida high schools. Additionally, a lot of the software that like William and I are developing, we want to retain some IP rights to that, so that can be registered under a nonprofit. And finally, tax evasion is wonderful, but for legal reasons, that's a joke. So, anyways, a little bit about our schedule, right? This is our schedule. You guys have all seen this spreadsheet before, but it's a little bit much. So let's break it down. Right now, we are on the Valentine's Day card workshop. We are still looking for a guest speaker, but it's very possible that we'll have a guest speaker next workshop. Good times ahead. We got a game jam prep workshop. There's something going on called the telephone game jam. Last semester, we did a pretty standard game jam, and we all had a great time. It was pretty successful. We had, I think, something like 25 participants. If I remember correctly, like between 3, 4, 5 teams. This time we're going to twist the rules a little bit, make it a little more exciting. And I just want everyone to stay tuned for that. We're going to have promotional content referring to that soon and explaining the details behind it. Then we take a week off for midterm, spring break. Your workshop suggestions will help us decide what workshop we do. There will be another game night. We had a great success with Splitgate last time. Just keep it in mind. And then hopefully we're going to have Joshua Fox, our beloved professor, as a guest speaker, filling in that slot for our 10th GBM. And finally, food as a semester end celebration. I just wanted to make sure that everyone is familiar with what the kind of schedule for this club is for the rest of the year, or the rest of the semester. So anyways, without further ado, the actual workshop, here we go. So using your computer science skills to find love. It is unheard of, but we're doing the unthinkable. We are doing the unthinkable. So what are we learning to make? Generally, we're learning a process today. We're not learning content, but this is some examples of content that I've made for augmented reality. You can see it's like a cake on the left, on the right there's a little snowman. Both of these track to an image. So what you do is you give someone a card that has a QR code and a tracker. The QR code itself can be the tracker, we'll talk about that. and then these 3D models kind of hover on top of whatever you put together for them. So what we're going to be making today is this little well, I've already made this 3D model for you because I couldn't possibly cover an introduction to Blender and 3D modeling today. But yeah, we're gonna have these little hearts hover above a sticker or some sort of marker. What aren't we learning? We're not learning how to 3D model and how to use Blender in depth. This PowerPoint will be released online, but these are links. We already have a 1.5 hour video by myself. There's also, of course, numerous tutorials on the internet that are really high quality that cover how to 3D model with Blender. And really, this, what we're learning today is limited by your 3D modeling ability. If you want to make something for someone, the sky is the limit if you know how to use Blender well. But you do have to understand how to, just make an object in Blender and give it some colors using materials. But what we're focusing on today is actually taking that from Blender and moving it into an AR platform, because that does involve a couple of tricks, namely baking. Today's going to be focused on baking. We'll talk about what that is. So motivations, why are we here today? I believe that good gifts they're personal, they're a reflection of your effort. This is an example of that. Yeah, CS, art, and love, right? Like where have you ever, no, this is just a joke. And then finally, the concepts that we're covering today are widely applicable. This is a game development club, not a Valentine's Day card club, but fundamentally, this is an example of real-time graphics. And just about everything that we do in this club is real-time graphics. It is real-time rendering. So real-time rendering tends to share some common techniques, and what we'll be learning today will be relevant to game development, absolutely relevant. So the game plan, we're going to talk a little bit about theory and context regarding like what real-time lighting and baked lighting is. We're going to talk about how to bake in Blender, material nodes, the UV editor, and then we're going to export to XR+, set up our project in XR+. But yeah, like I said, everything we're covering, highly interoperable. It's the same workflow as game development. It is real-time graphics. So without further ado, a little bit about 3D lighting. These are some pretty cool images here. This is the Stanford bunny, the Utah teapot, and the Stanford dragon. These are actually like really common 3D models. If you ever read some like research paper from NVIDIA on how they made some new path tracer, you'll always see one of these 3 models on display in some room with like green and red walls. It's a really, really common theme in the world of real-time graphics. And that's just because these models have been around since like the beginning of real-time graphics. That Utah teapot was like some 1990 something like 3D model that was parametrically made by some people trying out CAD for the first time in Utah. Like, cool. So let's talk about real-time lighting. This is Florida Man, by the way, from the Super Florida Man project. I'm sure some of you might be part of that, and those of you that aren't, cool opportunity to see what we're doing. But there's a difference between the images here, the one on the left and on the right. I mean, anyone have any obvious like pointers to the differences? Yeah, Andre, what do you see here?
On the right has lighting.
Yeah, the one on the right is well, that's not entirely, that's a good point. But it's not entirely accurate, because the fact is that the guy on the left also has like some lighting. I mean, we see reflections in his glasses. We see his
There's like shade on his neck.
There's shade on his neck. Yep, that's right. Here, let's look at another image. So image on the left, image on the right. The differences are kind of subtle here, but finally, let's take a look at this image. This is probably the image with the most contrast here. This is the difference between using the Eevee rendering engine in Blender and the Cycles rendering engine in Blender. And it's a really good illustration of the dichotomy in rendering between path tracers and real-time renderers. So you can really see the difference here. We can see some of the reflection of the train on the trees over here, that red glow. There's obviously shadows in one of these images. So huge difference. Why is that? The images on the right look better because they're examples of path tracing. Path tracing is a really computationally expensive process. It involves sampling each pixel numerous times. So I'm going to talk a little bit about what that means by just giving you like a little illustration on the board here. I'm actually going to lift one of the screens. If you have ever used like a 3D rendering program, all 3D rendering programs involve like something called a camera, and a camera is just like,
It's hard to see.
yeah, good idea. All right, cool. Lights. So 3D rendering programs have a camera, and a camera is like the position of the person in 3D space. So the way that your computer does it takes like the data of the 3D world and turns it into a final image is by, this is like an eye here, right? This is you, all right? You looking at your screen. And through your screen, you're looking at the 3D world. And so what your computer is programmed to do is it's programmed to go for every little pixel in our screen. See, this is like a screen here. It's going to shoot out a ray. And it's going to go like, oh heck, I hit a sphere. Okay. And then that ray might also pass through it and hit a couple different objects. I know at least one of us is in computer graphics right now, and is actually it's 4 of us are in computer, incredible. And so what you're doing is you're putting this together. This is a ray caster, and there's a really big difference between this and a path tracer. In path tracing, instead of shooting out just 1 ray per pixel, you shoot out like 30, 60, 100 rays per pixel. And then instead of just checking the first intersection, you then tell that ray to bounce in some random manner depending on the properties of that surface. So if that surface is red, that ray receives some like data related to how red it should be. And then if that surface is really rough, it bounces in some random direction. And if it's really shiny, it bounces in like a perfectly, pointed direction. And then it bounces again, and it hits some other object in our scene. And then it's like, oh no, what do I do now? And it bounces again until eventually you tell it, okay, that's enough bounces. You've gotten enough data. Now find the nearest light or something, like find a light source. And it finds a light source and then kind of like solves the data backwards from like, oh, okay, we hit a light source, we hit this, that, the other thing, and the final ray should look like this. And that's the difference between a path tracer and a raycaster. You'll hear the word ray tracing. Ray tracing is a generalization for both raycasting and path tracing. These are 2 very different things, but ray tracing has also become a bit of a marketing term lately, courtesy of NVIDIA. When in reality, ray tracing just means like any of these techniques, whether you're just doing 1 bounce and checking an intersection or doing numerous bounces and solving to the nearest light source. So anyways, enough of that. The key difference here is that a path tracer is really computationally expensive. Lots of samples per pixel. We're now seeing them show up in video games, again, through NVIDIA's like RTX thing. But the only way that they're getting away with that is by limiting the number of bounces. When you see RTX on for a video game, those rays are doing 2 bounces, and then the final image looks like this disgusting spotty image, like taking a picture at night with an old phone. And then what needs to happen is an AI takes that and performs denoising. So it looks at all those little spots and tries to make shapes out of them that represent the lighting of the image. But yeah, path tracers, really computationally expensive. I thought these pictures here are appropriate because the one on the left might as well be taken with a path tracer. I mean, we see beautiful reflections on the fire here. We see, obviously there's really good lighting. This on the right is a real-time render of a phone. Pretty lame lighting. There's some fake reflections right here. Each pixel is sampled once. Still, real-time graphics look gorgeous. We are in a world where we see games like, I don't know, Crisis 3 or Batman Arkham Knight. These are gorgeous games that use almost no real-time path tracing. They're not sampling pixels multiple times. Your computer would burst into flames. How do they do it? They do it by clicker. They do it by how do they put the real in real time? We see a phone in an oven there. That's a hint. They do it by baking. And so what baking is it is pre-computing lighting and then saving it to a texture. So you take all of these like photons and rays that were bouncing around, and you just paint them onto the surfaces that they hit. You go like, hey, light source, you hit this surface, all right, it's bright now. And then we'll let it bounce, and then whatever surfaces it hits after that, we'll paint the impacts onto those as well. So if it like hits a red wall and then it hits a white ground, it'll paint some of that red wall's bounce lighting onto the ground. It is saving lighting as a texture. This is an example from Unity's official documentation of what baking looks like. You can see over here we got like a little 3D model that has no shading. Then that 3D model is UV unwrapped. So we'll talk a little bit about UV unwrapping at the end of this PowerPoint because I think I'm going to finish early. But and so there's a light map which stores all of that like light data as a texture. And then you overlay the light map onto like the colors of the model and you end up with the like baked results. But those shadows are actually just painted onto the surfaces. They're not being calculated in real time. And if you were to move the model around, if you were to animate it or rotate it or change the light source, those shadows would not update. They would stay there and you get some very uncanny effects. I think like imagine using a pair of scissors to like neatly trace the outline of this and cut it out of the sheet of paper. You know, that shadow's still there. Like it's not following the object. I think it's a good analogy here. Okay, so baking, right? We've been talking about baking in the context of light so far, but you can bake more than just light. This is the set of checkboxes that defines what Blender is going to bake and how we're going to do that. So you can see here we got options like direct lighting and indirect lighting. So direct lighting says, hey, bake a single bounce into the world, and that's like no different than using like a raycaster, except just for the lights. So it's like, oh, it just draws like a shadow around objects, and that's it. Like it doesn't bounce them again and create smooth lighting. Indirect lighting, that's where smooth lighting happens. It's multiple bounces. Diffuse, glossy, transmission, emission. These are other sources of these are things that contribute to lighting. Diffuse here refers to color. Glossiness refers to glossiness, how like shiny is the surface. Transmissivity is like light passing through objects. So you know you can bake refraction. Not really refraction, but you can bake like diffraction, right? When light passes through a glass and then paints a rainbow onto a table or something, you can bake that onto the table. And emission, right? If you have like a jack-o'-lantern and the whole thing is glowing, you can bake that orange glow onto the environment around it. It doesn't have to just be like a very specifically defined light source. So anyways, let's that's kind of like the context that you need for today. The point is in an AR platform that is running on your phone, it's already doing a whole lot of math to try to solve the position of the phone relative to like the tracker. It's doing like convolutions on the screen, which is like finding high points of contrast and then tracking those points. It's working really hard. It does not need to be doing path tracing. So what we do is we bake the lighting in advance before we export it, and then you get really pretty results in the augmented reality platform. So for whatever you make. In this case, it's going to be some hearts. And honestly, the hearts aren't the best example of like the influence that baking can have on your final result because they don't have that much lighting going on. You know, they cast a few shadows between them and some ambient occlusion, but if you were to make something really complex, you know, for your boyfriend or girlfriend or whoever, you know, like something more personal, maybe you come up with something clever. Whatever you make, you probably want to bake the lighting if you want it to look prettier in the final result. Otherwise, it's going to look really, really like janky, I guess. It's the difference between making something that looks really good and really bad, and it's literally just like a couple of buttons. So that's what we're focusing on today. So yeah, if you want to, you can download this. I don't know if you want to follow along today. You don't have to, but if you want to follow along today, I'm gonna drop this download link real quick into our Discord, into muted mics. Is that the what?
Are you gonna present as though we could follow along?
I am gonna present as though you could follow along, just to like, you know, take our time here and explain everything. But you absolutely don't have to if you don't want to. Oops, yeah, OBS. You're good. Okay. So yeah, I'll let everyone take a second to download that blend file. And in fact, I myself, I'll be following along with you. Here is that Blender project. So when you open it up, it should look like this. We'll actually open up in this display, but I'm gonna not do that because it's going to drop frames on our recording. Our poor computer's CPU is not enough. Yeah. So I'll let everyone take a second. If I get like a thumbs up or two, maybe we'll continue. Hey, Jeremy got it. Merce is okay. All right. Sure. All right. What are you guys doing? I see. Oh man.
I'm gonna rock your world like.
You're gonna what?
I'm gonna rock.
You're gonna rock my world. Is that a threat? All right. So, okay. All right. Give it a few more seconds. When that screen gets to the bottoms, I think we'll call it. We'll get started. And if you do fall behind or something, this PowerPoint is designed to be pretty self-explanatory. You should be able to follow all these steps at a later time if you want to. So don't worry. Don't worry at all. The first thing we're gonna do is we're gonna split the view. So in Blender, to split the view, you just have to hover over like the edge of the screen. Like you have to hover over the edge of a different like section of your viewport and right click, and that'll allow you to split the view. We're splitting it into the shader editor. So the way that you do that is you click you click here. I'll use this laser pointer. Oh, oh, great heavens! I'm pretty sure. Oh my. Why is it lagging? Oh yeah, recording. Yeah, we are not streaming on Discord for a reason. Oh Lord. Okay, so we're not gonna use the laser pointer. We're gonna use the OS cursor. So yeah, point is like you click on the edge, and then this icon right here. Here, you'll see it again. Splits the screen, and then there's this icon on the top left of every section of the viewport in Blender. You click it, then you go down to shader editor, and it should open up some screen that looks kind of like this as like two nodes. What the shader editor is it's like a representation of every material as a set of nodes that define what that material is going to look like. Node-based shaders are quickly becoming industry standard. They've been around since like Unreal Engine 3. So yeah, shaders are really cool to be making with nodes. For each material, so right now in our 3D model, there's two materials. There's a material for like the terrain, the little like white square that we're on, and then there's a material for the hearts, which is like the red glossiness. And there's the same white material for the text. This is just an example of like two materials. If you were making something here, could be anything. You probably are going to use numerous materials, maybe 30 materials. Maybe you make a snow globe and it has like a tree in it and some textures that are like snowflake particles, and there's a glass material. All of these are different materials. What you need to do is for every material that you're going to bake, which generally is going to be like not the translucent ones, I guess, but like for our purposes, it's every single material, all two of them. You're going to go into the shader editor and you're going to add a new node. You can do that with the little add menu on the top. And that node is going to be an image texture. So you go add texture, image texture, just like that. And on that node, you're going to click the new button and you're going to make a new texture. What that does is it just creates a new image file inside of Blender for Blender to look at. And you're going to give it a pretty hefty resolution, something like 2048 by 2048 would be good. We're looking for square textures here, powers of 2. I won't go into details about why that is, but it has to do a bit with like, I think anti-aliasing. Marissa has a question.
I have a question. I'm really bad at Blender.
Yes.
What menu is it?
What? Sorry, what?
I don't see an ad at the top of my screen.
You don't see an ad on the, okay.
I'm not incompetent.
No, that's okay. That's okay. So here we are. Here's Blender, right? So what do? I right click on the top of the screen. I split it. And then on the right here, I click this little button on the top left of like every viewport has a button on the top left. See every single one. I'm gonna click on this one. I'm gonna change it to the shader editor. And now there's this add button right here. Morgan has a question.
I get what's
again, but slower.
Yeah, that.
Okay.
What she said.
Okay.
Back to high school.
So I'll go back to where we were. We were here. Maybe yours looks like this. Doesn't matter. It doesn't make a difference. You right click somewhere on the screen edge, somewhere on the edge of the 3D viewport where your mouse turns into like these two arrows. You do vertical split, and then you end up with two screens. And on the top left corner of each one, there's like a little grid with a circle. You're going to click that, and you're going to click Shader Editor.
Thank you.
And it cha-
There's like a little edit mode button on top of probably exactly what you're talking about. I guess that's a problem for me.
If it says edit and to the left of edit mode, like if this was in 3D viewport mode, and right here it says edit mode, to the left of that is a button. She's struggling. All right, that's fine. Yeah, that should be there. But okay, we'll figure that out afterwards. All good. Ben, what's up?
Ben.
Wait,
Brian.
Brian. I've been calling you Ben since like before the meeting started. You didn't correct me. Oh no. Oh no. Oh god. Oh great heavens. Okay, what's up, Brian? I'm so sorry.
No, it's fine, it's fine. I'm just thinking, I don't know if my laptop can handle 2048.
Your laptop can handle 2048.
You think so?
Yes, sir. Yeah, it can definitely handle 2048.
And if you can't, well, it's cold outside, so.
Jeremy's got a question. True. You can overclock in this weather. Jeremy, what's up?
So, do you need to add the image factor for each material or only for one of them?
So yeah, sorry. So let's go back to for each material. So what I do here is I create one of those nodes, and then I click the new button, and it creates like that texture. That texture is like global to all of Blender. So all of Blender has that like texture file now. All you have to do is then copy paste this node. So I literally just Control-C it, then I click on the other material, and I Control-V it into the nodes of every material. So that's what I'm doing. I'm pasting it into the nodes of every material. It's not connected to anything. This is a really quirky part of Blender. Why does it work like this? Why do you have to just have like a random image node that's not connected to anything to get it to bake? I don't know. Like that is actually so quirky, but that is how that works. So quirky. We're getting quirky with Blender this Valentine's Day. Indeed.
There's a 15-year-old.
All right, Tony. All right. Now. That is. Diana already has to edit the audio hard enough. We are on an ambient microphone. They can hear you. They can. I'm not using the lapel mic. We're on the ambient mic.
Oh. Well,
Yeah, everything that anyone's been saying is pretty audible.
I don't know what's coming.
Yeah, no, none of us know Tony. Jesus Christ. All right. Enough. So I'm going to go ahead and follow through here. Vertical split, shader editor, and I'm going to just follow along here, right? So I do add texture, image texture. I'm going to click new. I'm going to name it bake target smiley face just to show you can name it anything you want. 2048 by 2048. And then I'm going to go to the other material and paste the node, make sure that it's also, oh, I didn't hit OK. Oops. Bake target 2048 by 2048. Okay. Control-C, Control-V. There we go. All right. Yep, just like that. So now both of my materials have an image texture node just sitting around in the shader graph doing absolutely nothing, and that's perfect. So next we're going to unwrap the UVs into a light map pack. So all you have to do is in your 3D viewport, go into edit mode. So in edit mode, that's the little button on the top left. I'll show you how to do that in a second if you don't know. And then you're gonna press U, and you're gonna do light map pack. And what this does, I'll show you what this does. It's going to take this 3D model on the left, right? So the way you enter edit mode is up here, Here's object edit mode. You can just enter edit mode like that. And you press U while you're hovering over it, or anywhere in the 3D viewport here. And you go down to light map pack. It's the third option down. And it's going to give you all these options. You're going to set the image size to whatever resolution you set your image texture to. We've been setting it to 2048. I think that works. And then you're going to set the margin to 0.1. I think that's the default anyways. And you're going to hit OK. Your computer's going to lag for a second. That's normal.
You just select the thing, right?
Hmm?
You have to select the object.
You have to have everything in the object selected. Yeah, so like make sure everything's orange. To select everything, press A. So, and just like that, we've unwrapped it. Now you don't see any immediate results of that, but if you were to change your shader editor, remember that button that we used to go to the shader editor, if you change it to the UV editor, you can see the results of that. This is our 3D model on the left, cut up into all of its individual faces and splayed out on a 2D plane. So that is what a light map pack does. It tries to eliminate stretching. Marissa has more questions.
I'm so sorry. What did you click? What did you click to generate the light map pack?
So it's in the UV unwrapping menu. So when you press, you're in edit mode. You have everything selected on the left, and you press U. And U unwraps. U opens up the unwrap menu. So then you just click light map pack, and it'll work. But set the image resolution to 2048 so that it unwraps with the right margins. Yeah. Yeah, the reason that we need to set the image resolution right is so that it understands how much space it can leave between faces. Very important. Because otherwise it'll leave too much space or too little, and then you get really bad issues. In fact, we're going to see some visual issues even with this much resolution. But that's okay. They're minimal. Okay. All right, moving along. moving along. So, we've unwrapped the UVs into light map pack. What do we do next? Next, we do some final setup. This is already done for you. You don't need to do anything here, but I'm going to explain what this does so that if somebody goes home now and over the next week tries to make their own 3D model and follow these steps, they can reproduce the blend file that I've sort of provided you with, right? So it's very important that you are in the cycles render mode. Cycles is the path tracer. It's the only one that really supports baking in Blender. Then you also have to go to the world settings. That's the little red circle that looks like a Earth, and you're going to go to the background color and you're going to crank it up. Why are you going to crank it up? Because you want some ambient lighting to get calculated into the bake. You want some of that ambient like whiteness to kind of just fill your environment with light, so that the bake doesn't come out really dark. It's that simple. If you want, you can even change the background to an HDR texture, and then you can bake in like highlights that reflect that HDRI texture. So that means like your environment can be some pretty file that looks like an outdoor scene, and then yeah. Anyways, okay, enough of that. So we are here. If you've been following along, you're here. So again, what that means is cycles, GPU compute, and then additionally world properties. Our background color is white with strength of 1. Let me show you real quick what that does. This might affect our recording for a second, but this is our environment right now. If I set this to 0, our environment's black. There's no lighting to calculate. I'll set this to like 0.3 roughly, which is kind of what default Blender looks like. It's even darker. You get sort of dark result. Not pretty, not what we want. All right. Hopefully that wasn't too bad on the recording side. All right. So moving along. The next thing we're going to do is set the oven to 400. So this is, we're gonna bake. And the way that you do that is you go to the rendering properties. So in the properties panel, that's that thing on the bottom right of Discord or Blender. You're going to click the top icon. It looks like a digital camera. And you're gonna scroll down. If you're in the cycles rendering mode, then you will see a menu that says bake. And there's going to be a big fat button that says bake. And you're going to click it. And when you do, at the bottom of your screen, you're going to see that loading percentage thing pull up. It might run really, really slowly, and your computer might start to heat up. If it sits on 0% for more than like a minute, we can make some adjustments to make this a little bit more efficient. But generally, the adjustments that we need to make aren't in texture resolution, as Brian assumed, and he's right to assume texture resolution does influence how long this takes. But it's better to adjust how many samples we're doing. So again, that's how many rays we're shooting out of our lights and painting our surfaces with. Right now, the blend file that I provided you with has the samples set to 1024. 1020. Jeremy chuckled at that, I think, maybe. That seems like a lot. It's not necessarily. But if you turn that number down, your results aren't going to get much worse. You can set it down to like 200 or 100. But below 100 or 200, you're going to start to see a grainy result. And that's because like only, I don't know, 4 photons landed on that spot. And they're very different than the 4 photons that landed on the spot next to it. And you get some really noisy results. Again, not that different from how a digital camera takes pictures. It samples light hitting it over the course of like however long the exposure time is, right? So if you're underexposed, you get a really grainy image. Okay, so let me follow through with this. Nathan, what's up?
Professor Tomadakis, I have an error that's showing up on my info log, which is that there is no active image found for either material for
Interesting.
object text.
So for object text. Oh, it is called text. Yeah, that's right. My bad. Okay, so for each material, is there a image texture? Like node, like when you click on when I click on each material in the shader editor, is there a image texture node?
Yes,
there is. Cool. Okay, and then you go to the render button, which is you got to scroll down a little bit. Bake.
Oh wait, they both don't have an image attached to them. Like I need to click new and actually. Okay, let's go click new and
Oh, yeah. You got to give them an image file. Give them the same one. So only click new on one of them, and then on the other one, you're gonna click the little like icon to the left of new. It's gonna let you select the same image. So yeah, what you're creating is a texture. But what's up, Jeremy?
There's no like GPU compute.
Yeah. So you don't need a graphics card to do this. A graphics card just significantly accelerates the process. But no, you absolutely don't need a graphics card. I'm about to push this button on this computer right here, and it's probably going to mess with our recording. So as a result, I'm actually going to turn down our samples a lot. Wow, it's actually 4,000 samples. I'm sorry. So let me just set this to a much more realistic number. So the way that you do this, if your computer's taking forever, you can hit escape. It'll stop the bake, and you can go to under render. It's at the very top under sampling. Viewport is like for previewing stuff. Render is the number that we care about. So under render, maximum samples, you can turn this down to like 200 or something.
Where is that under?
Under sampling
so you
inside of the.
drop down.
It's under the render properties panel. So like where it's like cycles. The first thing under that is sampling. There's 2 sections under sampling that look identical, viewport and render. We care about the render one. And you're gonna change max samples to 200. That's gonna reduce the number of like arrays that are getting bounced around. Tony has a question.
Yes, Professor. So you set the default samples to over 4,000, but 200 is still sufficient, you say. So what is the big difference?
So the difference is like graininess, and sometimes in low light areas you want more samples. It's kind of like taking a long exposure shot in low light to get better results. Yeah, like if you had a model that has a lot of like dark areas that are occluded, you're gonna have issues. So there you go. I clicked bake at 200 samples. We can see that's moving pretty quickly. It estimates a minute 20 seconds left, but I think it actually takes off after 50%. So
I think mine got to 100% and then Blender crashed.
oh, that's unfortunate.
Just sort of
If Blender crashed, don't worry about starting over. What you can do is you can when Blender crashes, you can go to File, Recover, Autosave, and there are autosaves. You might also be able to recover last session, and it might have saved right as it crashed. Blender has a lot of like fail-safe kind of situations for it. Now, speaking of crashing, oh no, there we go. Oh, the operating system's like, oh no, come on.
no,
Any minute now.
Yeah, green screen.
Yeah. Come on. Come on. Hey, all right. Woo. So you're probably thinking, oh my God, nothing happened, right? Like it gets to 100%. It says baking map saved to external or internal image. Nothing happened. No, something did happen. If you go to the UV editor, so remember there's shader editor, there's also UV editor. If you go to UV editor, you can see the result, and that is our result. This is a good result right here. This is good. It's excellent. This is the lighting for every like surface of our object. So next step. We got about 20 minutes left. We're making a good time. So you hit bake. Set the oven to 400 degrees, computer melts down. The fruits of our labors. So the way that we see now the result is we have to create a new material on our object. This GIF is taken from my Swamp Hacks PowerPoint. So you can see different materials. I messed up and I didn't have enough time to go back and do it. But point is, you make a new material, you give that material an image texture as its color. And then the image texture that we're going to give it is the light map that we just created that has like all the colors and lighting. And then we're going to just delete all the other materials. And what it's going to do is it's going to assign that new material that we made to every like face on our object and fill it up with the new texture. And in the best case scenario, it looks identical to how it did before baking when you just turn on like the path tracer. So, yeah. Oops. We've had a couple of frame skips. Yeah, that's all right. That's all right. Understandable. That's all right. Are we having frame skips now? I think we're
Very
good.
recently, but
It was probably Blender
it was
baking.
probably
Yeah.
good now.
Cool. Okay. All right. So yeah, the way that we're gonna do this is we make a new material, we give it an image texture for color. The texture is whatever we just baked, and then we remove all other materials. So let's walk through that process in Blender. Here we are in Blender, right? So it doesn't matter what you're at here. If you're still in the shader editor, that's fine. On the right here, in the materials panel, we're going to add a new material slot. We're going to fill it with a new material. I'm going to call this bake result. And then I'm going to scroll down here and click this yellow circle to the left of base color. This yellow circle represents this circle right here. It's kind of like saying I want to attach a new node, one of these new nodes, to this circle. That's what this is, by the way. So right here, gonna click image texture, and see it created a node. That's how this works. And the image texture is going to be our bake target, whatever image file we used for that. And immediately we're going to see no effect. If I go into the material editor, we see no effect. But if I go to mat 1 and remove it by hitting this minus, everything turns red. Why? Because any face that was associated with mat 1 got filled with the next material below it. So everything is now on mat 2. If I remove mat 2, now everything is on the bake result. So this is the result of our bake. The lighting here, the reflections, the glossiness are not being calculated in real time. Whatever like ambient occlusion for these hearts here that are getting, darker near their bottom, not being calculated in real time. It's all calculated by the bake that we just did. So what we're looking at here is the result of the bake. Because there was like really strong ambient lighting, we're not seeing much of like shadows on the plane below it. But if we had instead done the bake with like a spotlight on this or something, the result would be significantly more intense. So you're free to experiment with that at your own volition. But you can also immediately start to see some of the unfortunate consequences of using a light map of low resolution or not. Like we have some artifacts going on. Artifacts are visual errors. You can see here on the F. Oop, you can see it's like black, a little bit of black going on here. These are triangles that were probably taking up less than a pixel and like not a single sample landed on them in the light map. Like there's issues like that, and there's ways to overcome them, but they're so minor that I'm not going to worry about them for the sake of our presentation so far. Yeah.
Would like the brute force solution to fix the artifacts just be to make the image resolution bigger?
Yeah, that's one of the brute force solutions. The other solution is to unwrap it in such a way that it's unwrapped better. Like
Okay, so it doesn't like automatically unwrap.
when you when you do a light map pack, it attempts to like it cuts everything up into individual squares and tries to minimize stretching by having everything as like a perfect square or triangle. And that just doesn't have great results unless everything is actually like squares and not like it just
So if it's not curvy geometry, like it's a bunch of like trapezoids, it would be fine.
we could here, let me show you. We could have unwrapped this differently. We could have been like tab U not U smart UV project, and we would have gotten this result. And yeah, you can obviously see it's we have to bake again if we want to target this new UV setup. But yeah, that's it's pretty abstract, you know, a bit of Jackson Pollock there, but inspiring stuff. So we're here, we have our final result, we're happy, this is great. So we're going to do one last thing now. We're going to export this as an OBJ before we go into our AR app. So to export it as an OBJ file, you just go to File on the top left, Export OBJ. The default OBJ settings are mostly correct, except for these two settings right here. You got to check material groups and smoothing groups. That is not too important. It just depending on the circumstances, but you probably want these checked. Smoothing groups makes sure that smoothing data carries over, and material groups makes sure that like what face is associated with what material carries over. I think. Not completely sure on that. OBJ isn't as common of a file type anymore. These days, FBX is the file type of choice. So let's do that. Let's do File, Export, OBJ, wavefront, and then we're gonna do Material Groups, and under Geometry, Smoothing Groups. And I'm gonna export it to my desktop as love.obj, and there we go. And we're done with Blender at this point. But don't close it just yet. Any questions before we move on to XR Plus? Tony.
Yeah, what was the immediate steps after baking?
Nothing.
It's finally finished.
You're done. That's great. Oh, my bad. Sorry. Yeah. So your bake is done. You create a new material on the object. So you go over here on the right, you're gonna create a new material.
That is under what side menu? Oh, the one
Under the red circle, the bottom red circle side menu.
Got it. Okay.
Yep.
that one's-
You're gonna create a new, so you're gonna hit the plus button,
Plus button.
then hit new to fill like the new material.
New.
Name it like, I don't know, final material, bake result, whatever. And then once you're there, you're going to scroll down to base color, the base color property. And you're going to hit the yellow circle to the left of base color. There's a little yellow circle.
Found it.
And you're going to click image texture in that big menu that pops up. And the image texture you're going to give it is the bake target texture that we just baked to.
All right. Okay. Trackpad's a bit slow.
It's fine.
And there we go.
All right. And then you're going to select the top material like matte 1. So just scroll up a little bit and click matte 1.
Scroll. Oh, and then
Matte 1, and then you're gonna hit the minus on the right, and then you're gonna hit minus again for matte 2.
Oh, you have to get out of that.
unable to remove materials.
Oh yeah, don't be an edit mode. Don't be an edit mode. Yeah.
Okay.
What's up?
Object mode.
Oh, okay. All right. Right. You're-
Now one too.
He's out of here.
The Three Stooges over here trying to figure things out, but that's all right.
Hold on.
You got it.
Wait, hold on, where's
The materials empty. No, wait, what? That's it.
That's all right. All right, I'm gonna move on a little bit, but you're almost there. You're almost there. If you did the bake, I'll come around afterwards.
We just baked it too long.
I baked it too long. You burnt it. We burnt it.
When we put the mix, we just scraped the part off.
Right. So, now what we're going to do is we're going to go to the website XR Plus. So go online and look up XR Plus. The first website that you find has something to do with rally car racing. Not that one. Second website. XR.plus. Okay, not xrplus.com, not plus symbol, xr.plus. And you're gonna come across a website, you're gonna make an account on it. This is the only free no-code AR platform that I'm aware of, which is cool. Like I looked up a lot of other platforms like this one. They are all expensive or they have some like weird nasty trial. This one lets you have up to 5 little projects going at the same time. So, you know, you get to burn through like a year's worth of cool AR cards for your significant other before you have to start deleting the like past experiences and so yeah, but it's extremely powerful. It honestly supports a lot of features. So once you're going to make an account, you're then going to navigate to where it says projects. We got about 8 minutes left here, but of course we can go over just a little bit. But we're almost done. We're really almost done. Like now it's just a matter of importing your OBJ file and clicking like 3 buttons and you're good to go. It's really that easy. So make an account and navigate to projects on XR Plus. And I'll let everyone take a second for that. What's up?
What improvements did you make to Snowman better?
What improvements did I make? Okay, so
2.2 megabytes. So
after you know, I knew I had to go back to the drawing board after I made Snowman. I was like, that's just not enough. No, so Snowman better is there's trees in the background. And that's it. There's trees. There's 3 trees in the background.
it's funny that Snowman better has the least amount of views.
Snowman, Snowman better. I thought I had him like holding like a thing that said like it was like a little like banner that said like Merry Christmas or something, but I don't. It's gone now. I don't know. Whatever. It's not.
Snowman better what?
Snowman better. Snowman better what? Right. But yeah, okay, I'm gonna assume that everyone's like managed to make an account at this point or is like on the project screen. So just gonna again, you can follow along with this at your own pace after the recording's done, the presentation's online. So I'm gonna move along. You make an account, you navigate to projects, you make a new project. Your new project looks like this. It's this empty user interface. That's what it looks like when you open up a new project in XR Plus. You're going to hit the add an item button. Okay, it's on the top left over here, right there. Add an item, and it's going to open up a menu that looks like this. You're going to click import a file, and you're going to import your OBJ file. That's it. You import your OBJ file. Great. You should be able to see it now. The next thing you're going to do is on the left here, there's a like left sidebar. You click tracking, you go to image tracking, and here you can create and edit your own AR markers. What is an AR marker? An AR marker is a like image pattern that is recognized by the AR app and tracks our model to it. There's different types of tracking that we can do here. There's SLAM surface tracking, which is a technique that I think is developed by Apple, and that allows your phone to be really spatially aware of the ground around it and where it is relative to that ground so that it saves the position of like whatever object you have on that spot. However, it comes with limitations. You can't do animations. There's a few limitations. It's a bit of a headache. Floating 3DOF, 3 degrees of freedom. That's like whenever you open up a Snapchat filter, there's like the dancing hot dog guy, you know. That is that, where you can move it around with your thumb and place it somewhere, but it's just kind of like floating in a way that looks like it's aligned with 3D space in your phone. Image tracking just tracks to an image. You know, you can actually, the coolest part of image tracking and giving someone a Valentine's Day card is that they can then hold out the card and look at it with their phone, and they can turn around the card, and it lets them like really inspect the model by actually like moving it closer to their phone. It feels a lot better than it sounds. And then there's face tracking and body tracking, which are both quirky. We're not gonna work with those yet. They don't. I wouldn't say they're fleshed out on this platform. So you can create your own tracker image file. Why should you? Because it's cool. It's personal. But there are good trackers and there are bad trackers. This is a bad tracker. Why is it a bad tracker? It doesn't have too many distinct features that a tracker can pinpoint and like track the tracking algorithm can pinpoint. So you see these little yellow spots here. These are points of contrast that it recognizes and feels comfortable tracking between different frames. So like, you know, your phone's kind of like taking a video there of this object, like it's staring at it. It's going to try to follow those points over time and recognize where they are. So this one, not great. This square, for some reason, performs pretty well because it's got points that are far apart and really high contrast and easily trackable. This is a cool image with a lot of unique features that are really trackable. It places some points at the end of the ears. Like all of this stuff is automatically done by the computer. It's just to be aware of. For a QR code is really trackable, but that doesn't always work in practice as well as the computer thinks it'll work. Like this isn't, I'm not sure that these ratings are honestly all that accurate, but just something to be aware of. If you have issues with this, you can change what image you use. So yeah, then just literally your object, if you imported it, it's sitting there in the 3D view. You can just drag it up in the web browser, make sure that it's sitting on top of the tracker, and yeah, now you can also play around with the lighting if you want. There's a little lighting button. You can change different light sources that are floating around in the world to give your hearts some specular highlights. And yeah, you're just about done. If anyone wants to experiment, you can scan the QR code and point your phone at this, and it might actually work. I honestly haven't tested this one. Let's see.
It's last next to this.
Let's see.
Well, this should work. No, I trust so it works. It definitely works.
So XR.plus opens up.
Just get the angle right.
Mhm.
Hold the right angle.
You let it access the camera, start AR experience. It's tracking okay on my monitor. This is too big. Is it working? That's good. That's good. It works a lot better on not screens for whatever reason. Screens are not tracked super well. So yeah, if you have this on like a handheld object and it's like really small, for some reason that tracks really well. So if you give it to them on a card, they can like move it around on a card. It works.
So it's better if the QR code is on a horizontal surface, right?
I mean, yeah, because if it's staring at it, it sits there. Yeah, it's better that it's on like
probably why.
Oh yeah, that's so yeah, that's
No.
oh here, yeah, you can point at one of these screens on the side. I'm like,
It doesn't say. It's a block to this image.
it doesn't track that well for some reason on my screen. Like it updates really slowly. But there are settings available that change how smoothly it tracks, so you can make it look and feel a little bit better. Those settings are in XR Plus.
Ours a little bit changed. Ours lacks the ability to like rotate with the camera's gyroscope. It's a little bit, it only like rotates when like I drag my fingers across.
I see. Yeah, that
It doesn't. It only rotates in the vertical axis.
I see.
Clearly, we just need to hit with a remote for to iron out the kinks.
Maybe remake it.
There's more. There's a little bit more. Just before I leave you today, I want to point out that everything that we've like learned and covered today is kind of minimal compared to what web AR can really do for us. XR Plus as a platform supports much more. Today we did tracking and lighting and textures in XR Plus. XR Plus lets you also do interactions. So you can have like a button, and when you press the button, you have like a character that is an actual skeletal mesh, and they can like run around and do things. You can program interactions into this. You can say like, hey, this button will, like, I don't know, imagine giving them a snow globe, right? And then that snow globe has a bunch of snowflakes inside, and each of those snowflakes is parented to a bone, and there's some preset animation that you made in Blender where snowflakes are like flowing around and doing their thing. You can make it so that when they push a button, the snow globe will shake around and play the animation. Cool, right? Like you can do so much stuff like that. And it's all there, it's all freely available. Face tracking is also pretty cool, but doesn't really work like as well as the Snapchat filters that you're used to probably do, you know. Yeah, like no, those require like some programming and stuff. Like the issue is when you do face tracking in this, you create some sort of 3D model, right? So say you want to give the person bunny ears, you give them bunny ears, but the bunny ears are like embedded inside of their head relative to like the model. So what you need to do then is have like the face cropped and then layered on top of the bunny ear chunk that's inside the head, and it doesn't do that. So instead you end up with like bunny ears inside of your face, and they look kind of weird. Yeah, compositing, yeah. So it's a little weird. But yeah, ta-da! Thank you for coming. Yeah, that's
It says concerns.
concerns. Yeah.
Stockholder value after this work.
Stockholder value. Nonprofits don't have stocks.
No issues there.
No issues there. We
NFT with this.
NFTs. We are not. Yeah, but also next meeting hopefully we'll have a guest speaker. If you want to see what our guest speakers have been like in the past, this guy's an absolute giga chad. His name is Colin Davidson. He's awesome. His videos on our YouTube channel, so you can always go back and watch that if you want to, if you weren't here for that last semester. But
We'll turn the video into an NFT. Wait, no.
No. Yeah, does anyone want me to explain anything? Does anyone want to stick around to see how I modeled those hearts or that environment? Like I can explain some of that. But yeah, that is our content for today.
So I stay here to see you do that, how long would that take?
How long would that? I mean, it depends
Yeah,
on how much depth I have to like explain it, you know? Like if I can take my time to really carefully explain how Blender works, and that would take like an hour and a half. That's why there's a video recording.
So, Professor,
Yes, students.
what happens when, in Blender, your button doesn't show up?
Your button doesn't show up.
The root of the problem.
Your button doesn't.
There's a couple buttons.
There's a couple buttons that are not
There's a
showing
few
up.
of them in Blender, it does
And
happen.
they just don't show up. And it's so sad because I couldn't do anything.
So what version of Blender are you in?
Incredible.
Bottom right corner of your screen.
2.93.4.
So Blender 3.0 is a bit different. That's one thing that comes to mind. 2.93 is yeah, there's a big update at 3.0. It's not huge, but it's a big one. I'll come over. Here.
Update my blend. I don't even know.
Should we stop recording? I think we should stop.
Okay,
recording.
that's.
Yeah. All right, cool. Well, thanks for watching. Like and subscribe.